Hey guys, welcome back. So in the last video, we talked about how to delete a node from a single linked list. So we saw that there are three cases in deletion of a node. Case 1 is we want to delete the first node. Case 2 is we want to delete the last node. And case 3 is we want to delete any of the middle nodes in the list. Now in this video, let's see how does the algorithm of those three cases looks like. So the name of the method is deletion of a node. It takes head reference and the location that needs to be deleted. So first we are checking that if the linked list does not exist, in that case we return an error message saying that the linked list does not exist and hence we can't delete any of the nodes. Now if the linked list exists, then the control goes in this else block. So this else if block checks for if location equals 0, that is if we want to delete the first node. In that case, all that we do is head is equal to head.next, that is if we want to delete node 1 and node 1 is not the only node in this list, then all that we have to do is we have to update head to point to node 1.next, that is node 2. So we'll update 111 here. So this will automatically disconnect head and node 1 and node 1 will automatically get deleted. Now the second subcondition was if this was the only element in the list, then do something else. That is, if node 1 is the only node, in that case tel will be pointing to node 1 as well, because node 1 is the first as well as the last node. So we will be having 001 here. So in that case what we need to do? We have to do the same thing, that is head is equal to head.next. So head.next will be null in that case because there are no more nodes after this. Now head is equal to head.next means we have to update head to null. So this links gets destroyed. Second thing we have to do is we have to update tel is equal to null. So instead of 001 we'll put null over here. So that will destroy this link as well. So now as we can see, node 1 is not being pointed by any of the references. So node 1 gets eligible for garbage collection and it automatically gets destroyed. Now let's say if location that user has given is more than or is equal to last. That means if we want to delete the last element. Now you might be wondering that why we have taken greater than is equal to. We should have ideally taken location is equal to last. Greater than we have taken just for extra convenience, so that in case if user gives a location which is bigger than the size of the list, still we will assume that user wants to delete the last location. So let's say this is our list having 6 nodes, and if user gives saying that delete node number 10, so now there is no node 10 in this list. So we will assume that last node is the one that we want to delete. Of course, there is no standard rule for that. You can always throw an error saying that node 10 does not exist. But I have taken it for my convenience that if user gives a node number which is bigger than the size of the list, then we delete the last node. So the first subcondition says that if current node is only node in the list, in that case we update head and tel. That is, we update head with a null value and tel with a null value. So automatically this link gets destroyed and node 6 becomes eligible for garbage collection. Now the second subcondition is that if node 6 or the last node is not the only node in the list, in that case we loop till the second last node. So we start from node 1 and keep going towards right. and then we stop at the second last node, which is node 5 in this case. So now all that we have to do is we have to update the reference of node 5 with null, indicating that there are no more nodes after node 5, and we have to also update tel. We have to update 444 instead of 5. So this will automatically start pointing to node 5 now, and the link between tel and node 6 gets destroyed. So now node 6 is not being pointed by any of the references, so it automatically gets destroyed. Now the third case was that if we want to delete any of the internal node, in that case all that we have to do is we have to run a loop from start till the previous location. Let's say if we want to delete node 4, then we start with the first node, go towards right, keep going towards the previous node to the node which we want to delete. So we want to delete node 4, so we'll go to the previous node, that is node 3, and stop there. Now the next step that we want to do is we want to connect node 3 and node 5. So for that what we have to do is we have to update it to 444, which is address of node 5. So now node 5 is not being pointed by any of the references, so it automatically gets destroyed. So now that we have understood how does the algorithm works, let's see what is the space and time complexity of this algorithm. So checking if the linked list is existing or not, it will take order of 1 time. If the node to be deleted is the first node, then we are updating some of the reference variables, which will take constant time. Similarly, if we want to delete the last node, checking that will take order of 1 time. If the last node is the only node in the list, it will take order of 1 time. But in case the last node is not the only node in the list, in that case we have to loop starting from first node till the second last node. So that will take order of n time. Then we update some reference variables, that will take constant time. Going into a else block will take order of 1 time. Now if we want to delete any of the internal nodes, then we have to loop starting from first node till location minus 1 node. So in the worst case we might have to travel almost the entire list, so it will take order of n time. Then we update some of the reference variables, that is a constant time operation. So if we add all of them, we land in order of n time complexity. Now the space complexity is order of 1. The reason is we are just using some of temporary variables here and there, nothing more than that. So those will take constant space complexity. So with this we come to end of this video. So in this video we have learnt that how to delete a node from a single linked list, and how does the algorithm looks like, and what is the time and space complexity of this algorithm. Now in the next video let's talk about how to delete the entire single linked list. Thanks for your time. See you in the next video.